In problem number 1, you have to realize that this is a two-section problem divided by a plus sign. I skipped the work, but what you have to realize over here is that this radical has an I, and this radical has an I, and they're multiplying each other, and therefore you're going to get an I squared equals -1. That's where the -1 in front of the 6 came from. The 6 came from rad 3 times rad 12 is rad 36. Rad 36 is 6. 4 times 2 is 8. Because this is a multiplication example, you just collect the 2 times the 4 times the negative sign from the I squared times the rad 36 is 6, and you get -48. Over here in the second half of the problem, the 3 times the -5 made -15. The I from here and the I from here made I squared, which is where the negative sign came from. And 32 times 2 is 64, and rad 64 makes 8. So I have a -15 times a -8, giving me a positive 120. Take away 48, 72. In problem number 2, we also have two sections. But here, only one radical has a negative sign. So the negative sign in here created an I, and the negative sign in here created an I, and there was no second I to make I squared, and so I have 6I instead of -6 over here. I have 6I over here, and so I ended up with 48I and -120I, and they're like terms, so the answer is -72I. In problem number 3, you have a monomial squared. There's no addition or subtraction between the 6 and the radical sign, and that's why you simply write -6 rad -10 twice, and that's why I have -6 once and -6 twice, and that's why I have a whole 10, and that's why I have an I squared, because if I have two square root -10s, I get an I from the first square root and an I from the second square root, and therefore I have positive 36 times -10 gives me -360. In number 4, again, I have a two-section problem because of the subtraction sign in the middle. First, I distributed 4 times 2 is 8, and then 4 times -6i is -24i. Then I moved over to here and did -10 times 1. And -10 times -7 gave me positive 70i. And then I combined like terms. Positive 8 and -10 made -2. -24i and positive 70i made 46i. And they're not like terms, so I have a two-part answer. In problem number 5, what I wanted you to see was that the 4 distributed up here because of the minus in the middle of the parentheses. This parentheses doesn't have a minus in the middle. The parentheses were just there because I thought it would be fun to make an ugly problem. What you have to do is ignore the parentheses because this is a multiplication problem. So all I have to do is multiply the 4 times the 6 times the -7. 4, 6, -7. The I from here, multiplying the I from here, gives me I squared, which gives me another negative sign. So when I have -168 from here times -1 from here, it's positive 168. Problem number 6 is a foiling problem. That's because your parentheses don't have anything in the middle. Go back and look over here, and you'll see a plus in the middle of the problem, a plus in the middle of the problem, and we saw a plus in the middle of problem number 5, I believe. I don't want to pause and have to go back. But there's nothing between the two parentheses, and that's what makes it a foiling problem, so watch out for that. 2 times -5 gave me -10. 2 times I, 2i. 3i times -5, -15i. And plus times plus is plus. 3 times 1 is 3, I squared. The I squared changes the +3 to a -3, and now when I combine like terms, -3 and -10, -13, positive 2i, -15i, -13i. They're not like terms, so I have a two-part answer. Go down here to number 7, and you'll notice that the multiplication is between two 2's and 2 I rad 3's, but one's plus and one's minus. So when I FOIL the same way I FOILed in number 6, I get 2 times 2 is 4, but from here I get a negative 2 I rad 3, and from here I get a positive 2 I rad 3, and they're going to cancel out. And at the end I have a positive times a negative is negative. I times I is I squared. Rad 3 times rad 3 is a whole 3. The minus I squared changed to plus, and 4 plus 3 is 7. It's fortuitous, SAT word, that 8 and 3 are near one another. It's fortuitous because between the negative 6 and the rad negative 10, there's no plus or minus, and that's why we sent the exponent in, so to speak, and we got 2 of these, 2 rad 10s, making a whole 10, 2 negatives, making an I squared, and we got a simple answer. However, over here, there's a subtraction sign in the middle of our exponent problem, and that's what makes it into a FOIL problem. Now we're writing these twice, the same thing, not a plus with a minus or a minus with a plus, but 2 minuses, because squaring means identically the same. Now when I FOIL, I get a 4, but I get negative 2 I rad 3 once, and I get negative 2 I rad 3 again, and they don't cancel out because they're both negative, and that's why I got negative 4 I rad 3. But on the end, I ended up with a negative 3, like terms with a 4, and that gave me 1 minus 4 I rad 3, not like terms, 2-part answer. Now we're ready to do solving. In this example, I gave you a problem, number 9, with no x terms. You had a 5x squared on one side, 2x squared on the other side, giving me 3x squared. And when I subtracted the 11 from both sides, I ended up with negative 27. You could set this up as a quadratic formula problem if you wanted to, with the x being b equals 0, but it's much easier to do the plus minus square root method. 3x squared, negative 27, x squared, negative 9, divide by 3 on both sides, plus minus square root gives us x is equal to plus or minus the square root of negative 9, which is 3 imaginary. Problem number 10 is much more complicated, but you're not supposed to worry about that right now. The first thing you do in a problem like this is distribute to get rid of the parentheses. 3x times x, 3x squared. 3x times 4, 12x. 8x minus 7 is still here waiting for its turn. The minute you see an x squared in an equation and there's an x term, you make it equal 0. So I minus the 8x and got 4x, and I plus 7 and got a plus 7 equals 0. Now I'm ready for the quadratic formula. I change the sign of b, plus minus big square root. I squared b to 16, minus 4 times a times c gave me 84, and 16 take away 84 is negative 68. Because I had a negative 68, I ended up with an I. 68 is 4 times 17, which is where the 2 came from, square root 4. And I don't do any cancellation until I'm ready to do all or nothing. Now I can do divided by 2, divided by 2, divided by 2, and I end up with negative 2 plus or minus I from the negative here, 17 with the 2 canceled out, divided by 3. In problem number 11, again, I have a parentheses, and because there's a minus in the middle, I know I have to FOIL it. So I got x squared minus 6x plus 9 from 3 times 3 equals 20. And because there's an x squared, I wanted to make it equal 0. So I subtracted 20 from both sides and got negative 11. Now I've got to be careful. When I change the sign of b, I get 6 plus minus big square root. I squared the negative 6 and I got 36. But I have a minus from the formula and a minus from the 11, so I ended up with negative 44. The minus minus made a plus, and the inside of the radical turned to 80, which is 16 times 5. So I ended up with a 6 plus minus 4 rad 5 over 2, and then I did divided by 2, divided by 2, divided by 2, and ended up with 3 and 2 rad 5 plus minus. Now we're ready for word problems, everybody's favorite. One number is 5 more than another, so I start by making x the word on the end. Then I add 4 to x, working backwards, to get the second number. Again, in problems like this, they work backwards. X is this number, add 5, get this number. That's what I have in my key. It says the sum of the squares, so I squared the x, and I squared the x plus 5, and the sum means add to 70. Again, this is a foiling problem because of the plus in the middle. I got x squared plus 10x plus 25, which I added to the x squared over here, and got 2x squared plus 10x plus 25 equals 70. Because of the x squareds, I knew I had to get it to equal 0 so I could use the quadratic formula. I changed the sign of the 10, plus minus square root, and when I did 100 minus minus 8 times 45 is 360, I ended up with 460 in here. I used my calculator. First I did negative 10, take away rad 460, the whole thing divided by 4. And again, watch out for the parentheses here. If you don't have them, you're going to get the wrong answer. So I got the answer to the quadratic formula, and then I added 5 in order to get the second number. So over here I have negative 7.86 with negative 2.86. Then I changed it to the plus version, and I got 2.86, and when I added 5, I got 7.86. So I had 2 negative answers and 2 positive answers, and we know that when we square numbers, negatives and positives have the same answers, so I checked over here, and 2.86 squared plus 7.86 squared came out to 69.9592, which is pretty close to 70 when you consider how much we rounded. Look how long the answers were, and we cut them off and made them only 2.86, 7.86. Because in problem number 13, they talked about a rectangle, I stopped and drew a rectangle first. Then it said that the length, mentioned first, was 3 centimeters less than twice the width was mentioned last. So again, I made the width x. Then I doubled it, working backwards, from the width. I doubled it, I took 3 away, and I got the length, which is why I wrote 2x minus 3 over here. Since length times width, or width times length, equals area, I multiplied this side by this side and equal to 232. Again, don't be upset by the centimeters squared. That's just the correct units for area. Then I FOILed the x. I didn't FOIL it, I'm sorry. I distributed the x and got 2x squared minus 3x. I subtracted the 32, so I would have equals 0. And again, I used the quadratic formula. I changed the negative 3 to 3, plus minus, and I had a big square root, where I squared this to 9, and I did 4 times 2 is 8, times negative 32, and I have absolutely no idea what it was, but when I added it to 9, I got 265. And now I'm ready to do 3 plus or minus rad 265, the whole thing divided by 4. So again, you'll notice the parentheses. 3 plus rad 265 divided by 4 gave me 4.82. And then I multiplied it by 2, and I subtracted the 3, and I got 6.64. So the width was 4.82 centimeters, and the length was 6.64 centimeters. And as you might expect, when I did 3 take away rad 265, I got a negative number, and you can't put negative numbers onto geometry problems, so I crossed it out. But I did sneak in a quick little check. I did 4.82 times 6.64, and 32.0048 is pretty darn close to the area I wanted. So I felt pretty good about 13. Part 4, the variation problems. In number 14, I said y was direct to x. That meant that y divided by x was going to come out to be the same number all the time, which is called the constant of proportionality, or the constant of variation. I decided to put y equals 5 on top with x equals 1.2 underneath it. And yes, I could have done it in a different order. I just picked y because I felt like it. So because y was on top over here, I took y equals 4.5 and put it over here and put the missing x at the bottom. And when I cross multiplied and divided by 5, I ended up with the x being 1.08. Remember, directly proportional means that y divided by x will always be the same answer, whether you're using 5 and 1.2 or 4.5 and the missing x. So set up a ratio. Over here, I told you that y equals 12 went with x equals 8, and I asked you for the constant. If they vary directly, the constant is found by doing 12 divided by 8, which I did over here. That's where 1.5 came from. If they vary inversely, that means that 12 times 8 has to have the same answer all the time. So over here I did 12 times 8, and it meant that the answer that repeats is 96. In problem number 16, I used an example where people did work over a certain amount of time. And common sense tells you that if you have more people, it's going to take you less time. And if you have fewer people, it's going to take you more time. So less, more, less is the key to inverse variation. So I multiplied 12 times 4 and found out that my constant was 48. And that meant that 8 times something had to be 48. So I did 48 divided by 8, and I got 6 days. So when the number of people that were available went from 12 down to 8, the number of days I needed went up from 4 to 6. This video is extremely long. I did not do the answer key to the computer problems. I'm sorry. I'm assuming that you can pause this or fast forward it to whichever particular problem you want. If you have any questions, don't hesitate to get in touch with me by email. Good luck with your studying.